Hello everyone, I am Mohammed Junaid and today I'll be presenting the final project brief for the COSC 6510 Data Intelligence class, which is titled CISA CVE-Driven Cyber Threat Intelligence Report. Just to recap, the problem that I aim to solve with this project is that there is an increased risk to vulnerabilities and attacks that organizations face because of the rapid integration and adoption of new technologies and services to these firms. My proposed solution thus is to provide actionable insights for these implementations by analyzing known records of common vulnerabilities and thus be able to assess their impact on these organizations. Moving on, this is the roadmap that I have come up with. Step one is going to be identifying the business need, which we have discussed in the previous slide. And step two is going to be the data collection step. For this, I have analyzed several datasets, both from public repositories and as well as Kaggle. We'll start off by pre-processing these datasets to clean them of null values and other imperfections, and then merge these datasets in order to create a superset. Step three is going to be data analysis. This includes statistical inference using graphs and other visualizations, hypothesis testing using probabilities, and also regression testing for the various features of the dataset. The step four and the final step is going to be drafting a final report for that has all the insights that have been generated. Moving on, the datasets that I will be using for this project are both from Kaggle, although they are compiled datasets from the public repositories developed both by NIST, MITRE, and CISA. The two datasets that I will be using both have both are CVE records. The first dataset contains most of the cybersecurity scores that I'll be using to assess these records, and the second dataset contains information on the products, vendors, as well as the common weakness enumeration, and also whether these vulnerabilities have emerged in the known exploited vulnerabilities log as well. The data analysis techniques for this project include hypothesis testing and regression analysis. For hypothesis testing, the first test that I will be performing is going to be the user interaction versus CVSS exploitability score. This assesses whether those vulnerabilities that need user interaction tend to have a lower exploitability score in general, and rejecting the null hypothesis would mean that the vulnerabilities requiring interaction do in fact have lower exploitability scores on a average basis. And the second hypothesis is going to be testing whether vulnerabilities exploitable over the network are more likely to be listed in the CISA KEV block, and accepting the null hypothesis would mean that it is not likely that if a vulnerability is exploitable over the network, it will be in the KEV listing. The regression analysis techniques used will be multivariate linear regression, quadratic regression, as well as log regression analysis. As an example, the multivariate linear regression is based on several impact metrics, including confidentiality, integrity, and availability of the vulnerabilities, as well as the attack complexity and scope. And we can use these to accurately predict the exploitability score. Although the CVSS already defines the exploitability score using its own metrics, we can use this analysis to explore the correlations between the other metrics as well. In summary, the combined dataset that I have created is a more business risk oriented one rather than a purely technical vulnerability assessment, and helps to bridge the gap between the products and vendors as well as the vulnerabilities they constitute to the IT ecosystems when they are implemented. The statistical analysis techniques that we have implemented will also help to generate a lot of crucial insights from the data set that will link several cybersecurity scores, their change over the years, to the vendors and products and the vulnerabilities that they present with. This allows technologists, shareholders, procurement teams, and security teams to make more proactive decisions, improve their resource allocation efficiency, and also stay on top of their compliance with the ever evolving cybersecurity legislation. Thank you.